it going? We're going to have kind of the same thing again today that we did, where we're going to keep algebra and geometry together. This is kind of an important thing for both of you guys. Those of you guys in geometry, you should remember this from last year, but I think we could all use a brief review. It's about putting things in simplest radical form. So most of your numbers, when you take the square root of them, give you irrational numbers. Now, you guys, we talked about perfect squares, right? The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2, right? These are nice, easy numbers to use. And in fact, if you kind of look at your multiplication table, it's these numbers right here, right? Now, you know, for those of you guys who are in algebra, we need to remember that there's positive and negative versions of these numbers. For those of you guys in geometry, we're really only focused on the positive numbers because we can't have negative lengths, okay? So what we're going to use them for are two different things, but in the greater scheme of things, we still have to know how to put things in simplest radical form. Now, most numbers, okay, most numbers. So say the square root of 1 was 1, and the square root of 4 was 2. Now, what about the square root of 2 and the square root of 3? These numbers, when we take the square roots of them, will give us what we call irrational numbers. So the square root of 2 is that, okay? 1.414213562. That number just kind of keeps going and going and going and going. It has no end. There's no pattern. Okay, it's an irrational number. Same thing with the square root of 3. Right, and pretty much every number that you keep going on is going to give you a number like this. It's going to give you irrational numbers. Okay. But sometimes there's a simpler way to express these numbers. For those a little bit later on in math, it'll be adding and subtracting those things. We went over some of that last year or 2 years ago for some of you guys, but we'll kind of cross those as we see them. But let's take a number like, oh, I don't know, 24. 24. If I said, hey, what's the square root of 24? Well, you break out your calculator and you say the square root of 24 is an irrational number, right? Now, we know the square root of 25 is 5, and we see this as 4.89, which is pretty close to 5, okay? But one of the things a lot of you guys like to get away with is just rounding that number. And depending on what you're doing, that's might be acceptable, might not be acceptable. We want to keep as many of these digits in there as possible because radical 24 includes, the way we write it this way is radical 24, it includes all those digits, okay? To round it to, you know, 1 digit or 2 digits or even 3 digits, it's really not doing those infinity digits justice. It really depends on what you're doing. If you guys are, you know, in geometry and you're building something and you need, you know, 4.89 meters, then yeah, you have to round it and your materials will bend a little bit to make it work. But if you're doing things that are very, very big or very, very small, or if you're doing, you know, just math, you want all those digits. Now, there is a simpler way to write this. And what we can say is this. Are there any of these numbers, any of these perfect square numbers that go into 24? And I know you're dreading this, but yes, you're going to go down your times tables. Yes, one of the numbers that goes into 24 is 4. If you want something to do, you can always say, all right, well, here's another 24. All right, 3 times 8. Well, that doesn't work. Where's there another 24? Oh, there's 4 times 6. 4 is one of my numbers, okay? So yes, you can simplify this. Now, if you know your multiplication tables, it shouldn't be too difficult, but, you know, I've met a lot of you guys, okay? So, again, what we can do is we can split this into radical 4 times radical 6, okay? So the square root of 4 times the square root of 6. And just to show you guys, if I said square root of 4 out from underneath times the square root of 6 out from underneath, it'll give us that same number. So this is a legal move we are allowed to do, okay? So again, now we can evaluate what is the square root of 4. Well, the square root of 4 is 2. And radical 6, that's it. So we would say this is 2 radical 6 or 2 times the square root of 6. Either one of those ways of saying it are acceptable. Okay? Just to check your work, 2 times radical 6 is that same number. Okay? So there's always an easy way to check your answers with you. So there's really no excuse if you have a calculator nearby to get any of these wrong. Okay? So I'm going to go through a few of those, and then I'm going to tell you about a couple snags you guys might hit along the way. Okay? So let's pick up another couple numbers. Let's do, I don't know. Let's do radical 27. Let's do radical, I don't know. We got a couple good ones here. Radical 28. Let's do radical 15. Okay? Okay, now, let's take a look. Number 27, is that one of my red numbers? No. So it will give me an irrational number. Are there any of these numbers that go into 27? So let's look for 20. Do we see any 27s on the list here? There's 27. So one way of making 27 is saying 3 times 9. Are 3 or 9 one of those numbers? Yes. Right there. 3 and 9 are one of them. 9 is one of those numbers, right? So what we can do is we can break this down to radical 9 times radical 3. My suggestion is you always put the perfect square, the red number, first. Radical 9 is 3. And radical 3 is 3. Okay, so again, let's double check that. Well, the square root of 27 was that mess. And 3 times radical 3 is still that mess. Good? Okay, 28. Let's try and break down 28. Again, 28, do I have any 28s on here? Or for 28, I'm looking for 28, I'm looking for 28. I found 28. Okay, now 28 is 4 times 7, or 4 or 7, any of these numbers? Yes. Okay, so what am I going to break this down to? Put the red number first, the perfect square first, radical 4 times radical 7, right? 4 times 7 makes 28. Okay, well, square root of 4 is 2, and the square root of 7 is 7. So let's go ahead and say the square root of 28. And let's go 2 times radical 7, just make sure we got the same number. Perfect. Okay? All right, 15. Now I'm looking for a 15. I got a 15 right here. There's a 15 right there. 15 is 5 times 3. Now, no 5s and no 3s. Do we have any other 15s? Well, there's one over here. But that's just 3 times 5. Any other 15s? No, that's it. So, in fact, there is no simpler way to write radical 15. Okay? The only way we could break this down any further is I could say radical 3 times radical 5, but neither one of those are perfect squares, so it doesn't help us at all. Okay? So sometimes numbers, even large numbers, that's it. They are what they are. That's it. There's nothing else we can do with that. Okay? Okay, so common mistake. Okay, let's take a look at an example. I'm going to say, hey, radical 32. Okay, now 32, again, not a perfect square. Do I see any 32s on here? 32, there we go. 32, right there. 8 and 4, right? Well, 4 is one of my numbers, right? So let's go ahead and let's say, what do we got? We got radical 4 times radical 8. Square root of 4 is 2, and 2 radical 8. Let's double check. Square root of 32 is that, and 2 radical 8 is that, and perfect, right? This is not in simplest radical form. It's not. The reason it's not in simplest radical form is that it's not as simple as it can be, okay? Whenever I talk about this, I always use this analogy. Okay, so we said this was 2 radical 8. What if I told you that 4/8 was equal to 2/4, and I said I'm done with that problem? Well, that's true. 4/8 is 2/4, but it's not as compact as it could be, right? This is not as compact as it could be because, in fact, there's another perfect square that goes into 16 and 8. I'm sorry, there's another perfect square that goes into 8, and that's 4, right? I could do it again. So 2 times radical 4 times radical 2, right? 4 times 2 makes 8, and the square root of 4 is 2. Right, so I have 2 times radical 2, or 4 radical 2. So you got to watch out for those, and just to show you that's the same number. It is, and it's just a better way of writing it. It's a more concise, accurate way of writing it. Or it's simpler, right? So we want to watch out for these, okay? So I'm going to do one more of those just so you guys kind of see where it is, okay? How can you avoid doing 2 steps with this? Well, if you guys are really good with your numbers and you spend a lot of time in grade school working with numbers like I did, you'll know that 32 is also another way of writing that is going to be square root of 16 times square root of 2, and 16 is also 4 times 4. So if you want to skip that step, you can go ahead and check for other square roots. Just a word to the wise, if 4 works, check 16, right? If 16 works, check 64, right? Because if you see, all those numbers are on my perfect square root list, right? But we also know that 4 times 4 makes 16. Actually, 16 times 4 makes 64. So we have these kind of strings and families that we should be checking, right? I'll give you guys another one. If 9 works, you should check 36. And if 36 works, you should check 81, right? Because 9 goes into both of these numbers. 9 times 4 makes this one. 9 times 9 makes this one, okay? And again, that's not a coincidence that 4 times 4 and 16 times 4 make this, that those numbers are all based around 4s, and these are all based around 9s. So again, these are good things to check. If one number works, you might want to check a bigger one, okay? So again, I'll give you guys another few examples, and then we'll call it a day. Okay. So what if I said, I don't know, radical 48? Okay. Well, 4 goes into 48, right? But again, we said if 4 works, we should check 16. Does 16 go into 48? 16 go into 48? It does. Okay. So I'm going to show you 2 different ways to do this. Okay. Either you could right off the bat say radical 16 times radical 3 and say that this is square root of 16 is 4 radical 3, or radical 48 is, that's 4 times 12, yeah? 4 radical 4 times radical 12. Well, square root of 4 is 2. Okay. The thing you just need to do is there any perfect squares that go into 12? Yeah. 2 times radical 4 times radical 3, right? 12 is 4 times 3. 2 times 2 times radical 3, which is going to be 4 radical 3. So again, you have your choice. If you're going to take these numbers and break them down, you just really need to be checking that last number, okay? So I'm going to pick 1 or 2 bigger numbers to do, and then we'll call it a day. I was intending this to be a little bit faster. Say I gave you a big number. What if I said radical 125, okay? Again, what's a perfect square that goes into 125? 25, right? So I say radical 25 times radical 5. Square root of 25 is 5. Square root of 5 is 5. Okay? Let's do one more big number just to show you guys a little trick that you might run into. Okay? What if I said radical 625? Well, what's a big number that goes into 625? Well, 25 definitely works, right? 25 goes into 625. Let's do 25. So we'll say, we'll break this down into 25 and 20. What's 625 divided by 25? 625 divided by 25 is, oh, it's actually, oh wait, it's 25 again. So, wait a second, I could do this actually twice. This is actually 5 and this is 5. Well, they all simplified, and that shows you something, that the square root of 625 is 25, okay? So even when numbers seem unfamiliar, if we start breaking them down into smaller components, we may find some surprises in the midst. That 625, what we didn't know was a perfect square, is indeed a perfect square, okay? So anyway, I'm going to give you guys a couple of these to do tonight, give it a try, and see how it works out for you. Again, we'll be back in our individual classes tomorrow using this stuff. In algebra, we'll be using it to express our answers in its simplest form. In geometry, we'll be using it to express the radius of a circle in simplest form. Okay, so I'll see you guys tomorrow. Take it easy.